Let me take you through the transformer explainer. As we have understood transformer in our last four sessions, in this session we will go through the visual representation of transformer. So transformer is basically a core architecture behind modern AI powering model like ChatGPT and Gemini. The same architecture is used for training a massive data set or an instance to general output. So if you see the transformer has embedding layer first, then the transformer block, and then the probabilities. So here if you zoom into an embedding layer, here you will find out first the tokenizer which divides our data input data into tokens. So here we have provided an example like data visualization empowers users to is an input, and then transformer model predicts the next word. So here each token is then converted into token embedding. So this is a vector of size 768. So each token is represented by 768 dimension vector. Now that embedding has been injected with the positional encoding and become an embedding with the positional information. That is an output of an embedding layer. So if you recall, we have an H heads in our encoder for each multi-head attention. So our transformer explainer has 12 heads and each head has an input. It processes the vector Q and K. First it multiplies vector Q and K, and then on top of that it adds the value vector on that and provides an output to the next layer. So if you see, we have 12 heads over here and each head differently scores. So here we do a matrix multiplication, then we scale down our values. In a multi-head attention layer, first we do a dot product of value key and query, then we scale down the values, then we perform a softmax operation on that output matrix, and then we add or then we multiply that vector with the value vector, and that way we get an output of our first head. So that way we have multiple heads over here. Around 12 heads you can see over here. Now each head extracts the different properties of the hand eye. Here we have dropout there, and then there is a residual layer. Similarly, we have multiple transformer blocks itself. So this is what we have discussed about NX. So here total 6 blocks of encoder and 6 blocks of decoder are present over here. So in the transformer block 2, we have 12 heads, and each head processes a data differently. Same process has been repeated in the encoder as we explained. First we do a dot product, then we do a scaling, and after that we do softmax, and then we add a value on top of that. So we pick up the output of the previous layer and add into output of current layer. So that way we retain the information what we had processed previously also. Same operation has been repeated for 6 times, and then from here onwards our decoder layer starts. 6 layers of decoder, and then we look out for the probability. So whatever vectors we have processed over here, do same dot product scaling and then softmax. Whatever output comes that has been passed to the residual layer, and the probabilities has been calculated. Based on the probable outcomes, we pick up that C would be the output which what we need. Let's understand a bit closely how probability is being calculated. So if you see, first we do a matrix multiplication with the vector Q and K, and then we do a scaling with the temperature. Here this is a temperature value. So temperature works by scaling the logit. So what the numbers we got is we call it as a logit. So we divided those logits with the temperature value. The low temperature value makes the large logits even larger and small ones smaller, favoring the highest scoring tokens to leading and more predictive choices we get with that. And if we have a higher temperature value, then it flattens the difference and makes the less likely tokens more competitive and leading to a more creative output. So if you have less temperature value, then model will behave exactly on the data what it trained. But if you want to have a more generic output, then your temperature value shall be higher. After that, we pick up a top elements of it. The top K filtering is performed on that. So what are the top 5 elements that can be an output of that is figured out. and on top of that, the softmax function is applied. So that is how we get a probability, like which function we need, which output would be the highest probability.